welcome Willie, welcome Laura, sorry, Laura. And welcome to some of my team. Glad to have you here. I know we've got a small audience today with spring break hitting a lot of the country. I got lots of out of office email responses this week. But I'm just so excited to have you here and to be talking Labdisc. So in today's session, we're going to be talking about some very quick live experiments you can do with your students, and these will be great as sort of beginning of class questions to get students thinking, or quick activities to just get them to hypothesize, run a quick experiment, and see what happens, no matter what age level you're working with. So some of the science concepts and math concepts might be a little too high or too low for your students, but it's all about just getting them to think and discuss about what they are doing. I see some folks have already started in the chat, so please use the chat throughout. I am going to be asking you to follow along and be experimenting just like the students would be. And while we've got a small crowd here, hopefully we get a good participation. So hopefully, I know some people who are watching these are potential customers, some are resellers, some are current customers and teachers. So just in case anyone here or watching the recording is not familiar with what the Labdisc is, it is part of our MimioSTEM suite of products. So we have our 3D printers, we have our robot, we've got our curriculum, and we also have a Labdisc, which is an all-in-one portable science lab you can take with you. You can go out into the field and do all sorts of experiments on one device. So I'm going to go through some of these sensors, but as you hear sensors that you are familiar with, I would love to hear either what you've already done or what kind of experiments you think you could do using these sensors. So on just our basic Gen Sci 1, we have air pressure, we have ambient temperature, as well as an external temperature probe. We have both current and voltage, distance sensor, so how far away something is, GPS, light, so how bright it is, a microphone for waveforms, as well as a sound sensor for how loud something is, and then relative humidity and a universal input where you can add in additional sensors. So now that you have an idea of what all sensors are in here, this is your chance to let me know either what you have or what you think you could do with these sensors. So please type some ideas in the chat before I get to sharing my couple sample experiments today. Let's see, temperature in the sun versus shade lesson with kindergartners. Yes, that was such a fun day. I actually got to go be a part of that one. Let's see, a light experiment with sunglasses with upper elementary. Oh, someone here says they do pH with like cleaning liquids and such as well, and comparing different cleaning liquids and household liquids. Very nice. By the way, if you have your chat set to just hosts and presenters, please change it to everyone so we can all see your wonderful contributions. But yeah, loving it. Okay, so definitely those are some good ones. I know a lot of teachers. Oh, here we go. Another one coming in. This is what I was just about to say. Set up a weather station. Can use the external probe to run it out a classroom window. All right. I would never have thought of just running it straight out the window. I've always sort of set up a little station outside, or if it's not going to rain, you know, just stick it outside. I still put it under a cover just in case, because it's not, you know, supposed to get rained or snowed on or anything like that. But yes, all of those different sensors, the humidity, the temperature, air pressure, all of those are great for a weather station. So wonderful. Okay. Here are some additional ideas, and feel free to keep going in the chat if you want to, but here's some of the things we do. What's the fuss? A similar experiment with pH and liquids that you both drink and use in your household. We're going to actually, that's one of the ones I've got set up behind me to do live today. What's the weather like? Shade structures. That's the one Laura was talking about with her kindergartners. That was a really fun one about building it. And I loved what she did, in that she had her students use recycled materials instead of like construction paper and stuff. So great way to reuse recycled materials as well. Sound interference, that one's all about sound waves and understanding things like noise canceling headphones. What's it like out there is a really fun one. That one actually, this was school inspired. We had a school in San Francisco ask us, hey, can we send this thing on a weather balloon to space? And we said, yeah, that sounds great. Do it. And if it breaks, we'll replace it because, we didn't test that. So, you can keep reading through here. We do water filtration activities, loads of different things. And with some of the external sensors, even things like heart rate that you can add on if you have just the basic Gen Sci. So first experiment, I'm going to jump in, but you all have to send your hypotheses in the chat. I rated my fridge and I was able to find, let me adjust my camera slightly. Here we go. We've got mango juice, filtered water, soy milk, and some water with a shot of lime juice just to give it some flavor. And I'm going to do the filtered water first, and then I'm going to use that as a place to rinse all of my subsequent ones. But I would love to hear which of these 4 drinks y'all think is going to be the most acidic. Now, I haven't actually run this experiment with these specific liquids before, so I'm kind of curious myself. Laura says water with lime. Yep, that's one of my high 2. Somebody else says depending on the concentration of lime juice. Exactly, that one may have everything to do with how much water I diluted it with. Otherwise, I think the mango juice is going to give it a run for its money as another citrus. But we'll see. It's all in the experiment. All right. So to run this experiment, I've got my Labdisc here under my MimioView document camera, so I don't know how well you're going to be able to read this on the screen. Willie says they also think lime juice. Wonderful, or Willie May. So right now I've just turned on my Labdisc. I'm going to click the pH button on the top of it, and that's going to change what it says on the screen to be sensing the pH sensor. And for this experiment, we're just going to read it straight off the screen. You can connect your Labdisc to a device and get a graph, but for this one, it's really easy to tell just from reading it on the screen. So, I'm all tangled up in my cord. It lives inside this storage solution here. So this is a liquid storage solution. You just want to make sure that when you're doing this experiment with your students, I typically already take this off and store it somewhere safe so that they don't knock it over or anything like that, because it doesn't have a lid that fully closes and you just don't want to have a mess. So, all right, let's start with whatever water came out of my fridge. And anytime I'm doing a pH experiment, I want to swirl it as much as possible around in the liquid for about 30 seconds before I take my reading, just so it has time to adapt. Some things will move pretty quick, other things will take a little bit of time. But you'll start seeing it go up or down immediately, but you sort of wait till it levels out. All right, so my fridge water is coming in around 5.6. It is still, somewhere right around 5.6. So this is definitely not distilled 7.0 water here that I'm working with. Depending on where you are, you could have an interesting time finding out what your specific water is and feels like, what its pH is. All right, now I'm going to save the popular vote for last of the lime juice, and I'm going to jump over to the mango juice. Now, if you look on the screen I'm sharing, just realized I should be bigger than it, shouldn't I? One moment, I'm going to go back and stop sharing my screen so that you guys can see me better. There we go. All right, back to my mango juice, and I have now made a mess, but hey, that's okay. That's what this table is for. All right, this one is definitely lower than my fridge water. We're coming in around 4 pH, almost exactly, and it's not really changing too much. So I'm good with this number. I just sort of watch to wait till it stops changing. All right, now before I go into my next liquid, I want to really rinse it out in water. That's why I did the water first. Wanted to make sure that the water was before I contaminated it with all the other liquids, we got a good reading on it. All right, soy milk. Sticking it in and swirling it around. All right, it is getting the most or the highest pH reading we've had yet. It's not quite yet to a base, but it's getting there. It continues to rise. There we go. We are above 7 pH. And so this is definitely the most basic of the liquids we are testing today, because knowing that there is lime juice in the water and the water itself was only at 5.5 is a pretty good indicator that our lime juice and water concentration will be a bit acidic. All right, now to see if this one drops below 4 pH. Yes, immediately. It drops right down. I don't know if my hand is blocking it, but there you go on the screen. You can see it is coming in just below a pH of 3. So I love to do this type of an experiment anytime I'm doing like science fair tables or demos, whenever I get just a little bit of time to experiment, because you can get students really thinking, especially if you put up liquids that maybe are not super normal. One of the ones we often like to do is Coca-Cola or other soda, just to see how acidic it is, because it often comes in even lower than something like lemon juice or lime juice. Now, I don't drink any sodas and I didn't run to the store to grab one, but that's another good one to just throw in the mix when you're running this experiment. Somebody has been trying along with it. I love it. Their water was 7.3. That's much closer than what I was working with today. So just a preview here from what the lesson plan. This is one of our lessons in my STEM kits, if you are familiar with our curriculum platform. In here, we have a career connection all about materials engineering. So I know some of you work in like CTE, career exploration programs. Let your students know, like, if you're designing a liquid that's going to be a cleaning liquid, it has to not damage what it's cleaning. If you're designing a paint, it has to not eat away at drywall. All of these different considerations go into making products. And then we have a whole bunch of extension activities. You can even use the pH probe. We have a whole lesson on soil sampling to get soil pH. So there's lots of different ways you can sort of branch off of this simple concept. All right, second experiment. For this one, I'm going to use, I didn't share screen. This sharing and not sharing screen is not my strong suit, but second experiment. We need more hypotheses going here. So I have a candle sitting back here on the table behind me as well. And this one, we're going to use our biochem model of the Labdisc. So if you have a GenSci, do not try and use your regular external temperature probe for this. We're going to be dealing with temperatures well outside the range of that particular probe. But for anyone with the GenSci, you can follow, or with the biochem model, go and grab your green cord thermocouple. So that is this guy, and it is a temperature probe capable of handling extreme heat like we're going to get while we're in a candle. So the question on this experiment is, which part of the flame is the hottest? The blue, orange, or yellow? And this one ties back into more middle and high school level conversations about convection currents and combustion and all sorts of things like that. So from an experiment standpoint, you can get into some really high level science here with this one, and understanding, chemical conditions and where combustion happens and whether it's complete or not and how much oxygen is in different places. But I don't want to leave that up too much in case you get the answers right away before I run this experiment. So I'm going to again stop sharing while y'all type in your hypotheses and go back to my document camera setup here. Now, obviously, this one is designed more for older students, and it specifically uses the biochem rather than a GenSci model or something like that. But if you do have just one of the other models of Labdisc, you can do some similar temperature related experiments, maybe not as much on a candle flame specifically, but on things like temperature of waters and things like that for really low students, you know, ice water, room temperature, hot water, and use a regular temperature probe for that. All right, we've got a couple guesses in the chat for blue question mark. I think if I didn't already know the answer, that would have been my guess as well. But I will not tell you what the answer is. I will instead demonstrate it. So I've got my biochem up here again. And with this one, I'm going to just try and put the very tip of this thermocouple in where the flame is itself. And I'm going to start with the blue, take it out, and we'll get sort of a reading on the screen again, just like we did with the last experiment. I'm going to try and avoid the wax. It's sometimes a little interesting. I think the official recommendation for this experiment is to blow out the wax first. Or no, then there wouldn't be a flame. Ignore that. All right, going in. All right, so I'm getting right around up to maybe 1200, but a lot of it was sitting in the, 800 to 900 degrees Fahrenheit here. Obviously at a high school level, you will probably be working in Celsius, but this one was already preset Fahrenheit, so I just left it the way it was. All right, so we've got our base layer of the blue at around 1200. I'm now going to kind of go just a little bit above it into sort of the orangish brown area. And here I'm getting actually a little higher reading. It's coming in around 1500 degrees. Sorry, my hand is blocking that. And then last test for the yellow, whether the yellow is going to be hotter than the orange, because the orange is definitely hotter than the blue. All right, so I'm in the top part of the flame now, and I am getting similar 1600. So there wasn't a huge difference between orange and yellow. And what I would normally do with this one is actually connect the device to the software and be able to compare the highs, because it does go up and down a fair bit. So when you run it through the software, you can actually see, where the peak was and not just have to be sort of looking at the screen generically. But yeah, I also had been told or taught somewhere along the way, I thought that the blue was the hottest part of the flame. And it turns out that that's just not true. So this is definitely one of those moments where I learned something when looking through this lesson plan, and your students could too. So then they could have a fun fact to go home with at the end of the day. All right, and now for our final experiment. Let me share the screen here again. All right, the last one I'm going to run with today before we run out of time is free fall. So this one has a nice math integration where we're going to be bouncing a ping pong ball under the distance sensor on our lab disk and see what it looks like when it bounces. So anyone who wants to submit a hypothesis can put in one for what the graph will look like. And this one, I am going to leave my screen sharing up, and I'm connected to the software so you can see how I would set up that experiment and run it. So we have sort of upside down arcs, we have right side up arcs, and we have this one that's a little bit more linear to guess the distance away from the sensor as a ball drops and bounces. So to set this one up, I simply have connected my lab disk via Bluetooth, and then I'm going to make sure distance sensor is active, and I do want quite a few samples per second, and I'm going to go to 1,000 samples total. All right. So I'm going to detach my pH probe here before I get started, just so I have one less thing that can get in the way. And then the distance sensor is actually located on the back. Yours will have a cover over it. I broke mine off, but the good thing is it still works just fine. And you shouldn't break yours off if you aren't being silly and trying to simulate an earthquake without taping it down. That got changed before the lesson plan got published. All right, so I'm going to bring my mouse with me. grab my ping pong ball. All right. So we'll see how quickly I can move into position to start my experiment and then drop the ball. With this one, you want to make sure you're about 40 millimeters below the ball when you are below the sensor when you drop it, because that's the minimum on this sensor. And the other risk with this one, as I run it, is it is important to have a nice flat surface. It may take a few tries before you get a nice clean graph, because if the ball bounces out from under the sensor, you get a graph similar to what I did. This is easier with two people. I have one student holding the sensor, one student holding the ball normally. Take two. Okay, there we go. There's that good section right in the middle there. That is showing us what we want. So I'm going to stop my experiment and just use the zoom in function here to look at, this is really what the graph that we were looking for looked like. So if I go back to my PowerPoint presentation, that is graph number A, or letter A. So yeah, this is how each bounce is getting a little smaller, but because we're looking from the top and not the ground, the classic bounce arch is upside down, is inverted. But if your students are into animation or anything like that, you can tie that into how you would animate like a ball bouncing, how each time it gets a little lower. All right, so I hope you enjoyed these 3 really quick experiments that we did. If you feel like throwing in the chat any ideas you may have gotten, or if any of these are ones you want to try with your students, I'd love to see that. But I also know we are running short on time, so I'm going to move on to the next slide. And if I see anything, I'll be sure to share it. Ah, yes, pH 1. Yay, I love the pH 1. There's so many different ways you can take that. Here is my email, and I'll drop that in the chat as well. So if you have any questions or anything like that about the experiments I ran, feel free to reach out. I do also want to end with a quick sneak preview. We have a new version of the Labdisc coming this summer. It is a smaller Labdisc, and it is called Explorus. And all we're really saying right now, because this is just a quick sneak preview, is that you will have a programmable screen that can help add visual clarity to what some of the sensors are doing. So this is directed specifically at elementary, and it is really designed to help those younger students who, maybe aren't comfortable with decimals or anything like that. So it's limited sensors, not as many as the GenSci has, but it even has some animation and code built in. So we are super excited for this. I'm loving the emojis I'm seeing hopping in the chat. All right, so join us next week. We're going to be talking more Labdisc as well as 3D printing with Preston, as he goes over 4 steps for designing the perfect science fair project. So whether you're at the end or middle of science fair season right now, this will be a great chance for you to get some good tips and tricks you can pass on to your students. Thank you so much, everyone, for joining and participating. You made this a wonderful time, and I'll stick around for some questions. But otherwise, I will look forward to seeing y'all in a future STEM Wednesday.